Andrew just went live on Twitch.
All right, so today we're going to be taking a look at this touch bar from yesterday that you're probably not going to believe decided to magically fix itself. So Paul had an excellent recommendation. Paul suggested that since the issue was with corrosion by one of those USB-C controllers on yesterday's stream, that I try every single port and see if it worked. And it did. But then I went back to the ports that didn't work yesterday, and they worked. Why? I have no idea. I took the machine, I gave up, I put it down on this chair, so that I could come back to it today, and that same machine that you'll be able to see right over here, in the same solder by the screw hole where I tried to do the short detection. That's where I attach my wire to detect the short in the 3-volt rail. That's the capacitor that I replaced. That's all crooked because my soldering's always crooked. And if I plug it in on the same side as yesterday, you'll see that it's not just putting out. It's not stuck anymore. You can't make this stuff up. I tortured myself for hours with this yesterday. And if we check with the meter, let's put the meter into RS-232 mode so that you can see it on the screen. Oh, it's the fuse on the bottom of the board here. $20 volts. And if I were to check for PP bus G3 hot, 13 volts. And if I were to check for CPU V core right over here, A2B donated 10. Love 28B. A28B. Love your content. Thank you. Thank you for watching. And thank you for letting me know that I need to move that thing to where it's actually visible. I appreciate that very much. You can see we get 1.1 volts on CPU V-core, which means that this is turning on. So did I fix it? Did my chair fix it? Did Paul fix it and secretly not tell me? Who the hell knows? But that touch bar was fixed. So now we're going to move on to the next one because we are not afraid of touch bars here. So let's go on to the A1708. Now this model is one that I have not had a schematic for, so I haven't been able to do any type of real in-depth diagnostics until now. Thanks to a site on some random corner of the internet that's probably located in Russia, Romania, or somewhere where FBI doesn't have access, we have schematics to and board views for the A1708 model, which is the 820-00875 board. So at this point, the only schematic that we're missing are the schematics and the board views for the A1707. Now, it would be a real shame if somebody were to release the schematic and board view to the A1707 MacBook Pro 15-inch Touch Bar. That would be a terrible thing to have happen. I would be very aggravated and very annoyed if someone were to make available A1707 schematics. So definitely don't make them available. If you're in a factory, if they're on a desk somewhere, or they're on a flash drive and you're able to leave with that and put it on the internet, don't do that because that would be wrong. Now, let's get over to troubleshooting this one. So this here is the A1708 Touch Bar, and let's take a look at what this board looks like, and also let's take a look at what it's doing. So we're going to open up that schematic and that board view. It smells like fresh board view. Ah, that's beautiful. Oh, man. A1708 schematic and board view. Joy. Right to Repair, sponsored by random Russian websites. Okay, so we're going to take this little board here. That's my board. Isn't it pretty? Look at how pretty that board is. Crooked soldering is your warranty sticker. It sure is. So, do you have screens for A1706? Not yet. They're still insanely expensive. We are looking into getting something that's not insanely expensive. We're trying to get anything in the sub 250 range, and we may have a lead, but no news just yet. And they need to be in that range in order for it to be remotely worthwhile for us to do. So we're going to plug this in. Do note that Apple has taken they've gone downhill in that they used to not solder the charge port to the board. First, this is the funny thing. So Apple realized that most people trip over their charger, so they decided, let's make the charging port separate from the motherboard so that you don't ruin the whole motherboard if somebody trips over it. People were still tripping over it and ruining charge ports, so they thought, okay, let's make a magnetic charger that just disconnects if you trip so that it doesn't ruin the machine, doesn't ruin the charger, doesn't ruin the DCN board. That was great. Then Steve Jobs dies, and they go one step backwards, which is they have a charger that's no longer magnetic, but at least it's not physically attached to the board and physically soldered, I should say. Now, with this machine, Apple has gone full dumbass and gone back to the design of all those terrible cheap PC laptops that people hate so much, which is where the charge port is directly connected and soldered to the machine. So, yeah. So that MagSafe is one of those things that I can't really say anything. I can't really say anything wise about because I can't be a wise ass because it was a really good feature and PCs really should have implemented something like that sooner, but they never did. But Apple has now taken that away. So let's figure out first of all where we would expect voltage to start coming in here. So we're going to find that charge port. We're going to open that up on the screen and get started. So the charge port is going to be J3300, it seems, and that's going to be where we just plugged in. Static from the chair fixed it. Well,
That was my vote.
yeah, that's probably what it actually wound up being. Pepe fixed it? A lot of people think Pepe fixed it.
He may have.
Is there a place that I can mail or talk to you privately? No. I'm sorry. Doesn't exist. iPad Rehab is correct. Is this the one with 4 TriStars? Yes, this is the one that has 4 TriStar, I suppose, if you want to call it that. So let's take a look at J3300. And what are we going to expect to come in on J3300? So we found text on page 31. Hello. That doesn't look like a connector. That looks like a chip. Oh, this is really... Paul, look at the... Theodore said the chair fixed it because it also absorbed your knowledge through your rectum? Huh? Well, thanks for the $2, but what the hell does that mean? Look at how they placed the connector on the board. They made it look like a chip.
What the hell?
Yeah. That's confusing. Why? Why?
Is it at least following the scheme where inputs are on one side, outputs are on the other or something?
I have no idea. All right, so it looks like PP20V USB C XA VBus Con is what we're looking for. All right, this thing. So where would we find that? Let's follow that along. So that's going to be on F3000 and F3010. So F3000, F3010. It's going to be on the other side of the board, so we're going to flip the board over. Jessa said ass is profanity. No, it is not. That would mean that if I were to talk about a baboon, that I would be being profane, which certainly is not. Okay, so it looks like this fuse and that fuse, and I'm guessing that you have a different fuse for the different ports, or a different fuse for when it's turned around a different way. So it looks like this board is giving us, let's see, looks like this board is giving us, how many volts? 5 volts on input instead of 20. So what did we learn from yesterday? What we learned from yesterday is that the PP3V42_G3 hot of the touch bar models and all the new 2016 ones is PP3V3_G3 hot. If we don't have PP3V3_G3 hot, none of the ICs that do the communication with the charger are going to talk to the charger and get their requested 20 volts, and the machine will never turn on. So let's take a look around and see if PP3V3_G3 hot exists on these boards the same way that it exists on the A1706 model. Going back to the schematic over here, we're going to see where that's created from and if that exists on this board. And it seems like that does. So we're going to find that on the board view software here. And it's going to hit escape. And PP3V3_G3 hot. Hi, I'm a biomedical equipment tech. This is the first time watching live, but long time viewer. Well, welcome aboard. You probably know a lot more than I do about this stuff. So I'll be coming to you for questions. So here we go. So that was right over there. Now, before we check for a short circuit, it's important that you always unplug power going to the board. You don't want to have power going through your board while you're sending power with a multimeter and trying to measure what comes out the other end. So it looks like we can find that piece right over here. And we're going to measure. Do you prep before recording, or if your flowers we see live? Flowers. I prep before recording to the extent of taking the machine out of the computer. And sometimes I kind of try to get an idea of what the problem is beforehand. But then there are machines like this where I have no idea what the issue is beforehand.
Your app changed flowers.
What was... No, it said flowers on my screen. Okay, so it doesn't look like we have a short circuit to ground there. Let's see if PP3V3 is showing up. And it does look like we do have PP3V3. Yep, that's present. So, okay, so why are we stuck at 5 volts in the charger? All right, let's take a look. Let's see what this board looks like. So, oh boy. What's this? Ah, this is why I left this in Paul's till. Oh. Lewis, you've got mail. I'm scared to check. Okay, so where... I'm going to take a guess. The component's supposed to be here. Ugh. And we have a broken via in the corner right up here. That could be for something important. That's clearly broken. Where is Stuffed Pepe? Stuffed Pepe is up there. Paul put him where I can't reach. That's...
Oh, you know how long I took to get him to sit there?
Stuffed Pepe is right here. He's going to sit on the microscope for now. So, what is that for? Hi, Lewis. Evaluate the function. If the value is not a rational number, round your answer to the 3 decimal places. Cosine of h up to the -1 up to the 7. I'm not doing your homework. What kind of please bro channel is this? Go over to iPad Rehab if you want me to do your homework. And stop picking your lips. Are you getting a new website? What makes the current setup 4600? No, I've given up on the whole idea of getting a new site. Screw that. Current site is fine as is. And I'm not wasting money on that. All right, so let's try and figure out, let's go back on topic here and figure out what is going on with these corroded vias and if they are for something important. So anytime I see something that is clearly corroded, the first thing I do if I see something that is very, very clearly corroded is try and figure out if that is for something that's actually important or if it's for something that's just nonsense. You know, I don't really care about something like the SD card slot on something working. I don't care about like aligned to the keyboard unless it's the power button. I don't care about that stuff yet. I don't care about it unless it has something to do, or a sensor issue, if the thing is dead. So we have to ascertain what is important first, and we're going to have to see what this thing is. So it looks like this is some type of ESD diode over here. And ESD diode, I mean, that seems as important as calculus 2. It doesn't seem like something that I would prioritize. So let's just take a look at D3409. And this, so this is a diode, some type of ESD diode. Boring. Don't give a shit. Moving on. Now, if we were to look at the rest of the stuff up here, there are capacitors to ground on PB3V3S4. That does not seem like something that matters very much. So we continue moving on. Now there's also other components knocked off right down here, and I'm going to zoom in on them so that you could see them more clearly. And if we go down there and look for those components, we'll see that there's, let's see, we got 2 diodes. Here we got let me try and locate which ones those are. So that's more diodes. That's a capacitor to ground and a capacitor on some rail to ground. So I don't think that those are going to be major causes of malfunction. Now we're getting closer to something that I think may cause malfunction. Here we have the CD3215 IC, which is going to do all of the communication with this chip is going to do all communication with the charger. This is the USB-C port controller. So U3100 is the chip that's going to be saying, I want 20 volts, I want 5 volts, or hey, this is a USB signal, hey, this is a DisplayPort signal, hey, this is a Thunderport signal, or PCI Express signal. This is going to be the USB-C mux, and there's something missing right by it on the top. So if we go over here, we'll see that there's also a missing pad, which Paul's going to have to reattach, and so that is a missing pad for R3000, which sits between the chip and PP3V3_G3 hot. So that seems like a winner. So capacitor to ground on random lines, I don't really care about. Who cares? But this is a resistor that sits directly between a main power line and the IC that's going to control the charger. See? PP3V3G3 hot, and on the other side, the chip. So that is no good. And if that is also burned, there's a chance that the ball under the chip may be burned as well. So let's take a look and see what's going on. Nobody better be doing anybody's Calculus 2 homework in the chat, because there's no way that they're going to learn if somebody else does their homework for them. Now let's see if my balls are present or if they're corroded. Okay. This is... Okay. Do we have balls or are they corroded? What do you all think? You're not allowed to look at the balls if you're still doing calculus homework. Nor can you think about them. So, it looks like that ball is still present. It should be the fourth one, as you can see from the board view software. That is the fourth one from the upper left. And I actually can't see that ball because it's hiding behind a damn capacitor. See? See? This capacitor is not allowing me to see whether the ball is there. But that's fine. That's fine. If it doesn't work, that just means more work for Paul. So, we're going to do this. So we got to start by running a jumper wire over here to bring PP3V3 back. And we also need to put that resistor over there. But the problem is I don't have that resistor because I don't have a donor board. So let's see what the value of that resistor is first. So the value of that resistor, according to the schematic, is 0 ohms. 0 ohms. and 1/20th of a watt, which means I may just be able to put a jumper wire there. Now, before I put a jumper wire, anytime you're going to jump or something like this, you want to make sure that there's no short circuit. If you're putting a jumper and there is a short circuit, bad things will happen. So we're going to check and see if there's a short circuit prior to placing any jumper wire over there. So let's check and put the meter into resistance mode. What's up, Paul Daniels? How are you doing? Is Ross anywhere near Bushwick? I haven't lived in Bushwick for a really long time. I haven't lived in Bushwick since Mexican burrito places outnumbered expensive hipster bars, which is a long time ago. There was this one really cool place on 247 Star Street. I could eat there 3 to 4 times a day. It was just amazing, like absolutely amazing. I loved it. It was right next to the train too, and I remember going back there one day because it was worth it to ride my bike there just to eat, and it was replaced with some hipster bar where it was yuck, boo. Sign of the times, I'm afraid. So let's put the meter in ohms mode. I forget the name of the place that used to be a 247 Star, too. I wonder if they moved somewhere. And that was great. Okay, so it looks like 0.3 million ohms, and it's not even showing up on the screen because B&K software is awful. So we don't have a short circuit, which means we could potentially safely jump PP3V3 _ G3 hot to that pad. So let's take a look on the board view software and see where we could find that. Where could we find PP3V3S3? It looks like we can actually get it from right over here next door. So we could actually jump from here to there. Let's jump it. But admittedly, there's a good chance that this chip is actually not good anymore. Because think about it. If there was some type of shock that was hard enough to actually knock this off of the board, chances are the chip itself is going to be defective. So I'm thinking maybe I should replace the chip as well. So I'm thinking replace the chip. Replace the chip. Release the memo. I mean replace the chip. Okay, so let's go on and replace that chip. Can you please explain why engineers decide to put 0 ohm resistors? I believe they put the 0 ohm resistor because they want to use it as a fuse. That's my guess. But I'm not an engineer. I'm just a Twitch streamer minus the mammary glands. So let's remove that chip. Let's repeal and replace our CD3215. I should probably make sure I still have those in stock before doing that, but that's not... Where's the adventure in that? So we're gonna preheat the board a little bit before we go on.
What chip do you need?
CD3215.
No results.
What? What kind of shit website are you looking at?
Microsolderingsupply.com.
Note to self, fix search function. I'm trying to scroll and read chat and do this at the same time.
Oh, I found it. Hey, that's one of the new pictures tonight.
Can you test the chip prior to replacing it? Not really. Look, Jess said iPad Rehab is here. Paul said something that it's probably best you're away from the microphone for, but... Okay, it looks like all the balls look lovely under that. So we're just going to remove most of those. Oh, we have them left. Some left. Wow. Is that it? Or do we have more?
Plenty more.
Oh, beautiful. Good stuff, good stuff. So it looks like that ball did look nice after all, so taking this off is most likely a waste of time. Yeah. Oh, sorry. Dogecoin. Dogecoin. Wicked. Wicked good. How often do you wick your pads, Paul?
Every time.
Every time?
Every time.
Every time?
That's what iPad Rehab does.
In which video did you see her do that?
Everyone.
So what? Yeah. Do we sell the wick that iPad Rehab recommends?
Yes, we do.
Where do you find it?
Store.rossmangroup.com,
Absolutely.
where you can search for Wick and find our favorite brand of Good Wick.
I think you could actually search for Jessa and find our brand of wick on the site, depending on whether the search feature allows that.
Can you really? I will test that.
I just knocked off that little capacitor.
Awesome. So go to store.rossmangroup.com and search Jessa, and you will find Jessa's favorite brand of wick.
I deserve that for making fun of Jessa. This is karma.
Did
That's
you just
total
pull
karma.
pads?
Huh?
Did you just pull pads?
No, I just knocked off a capacitor for being an idiot. Total karma. That was karma. Alright, that'll flow back into place. How many boards do you work on or repair in a day? Anywhere between 0 and 10. You're smashing those poor components. Not smashing. Okay, maybe smashing a little bit. Fine, we'll give him a new cap. That'll get soldered into place with the hot air in a moment anyway. I have a T430. Can you help me find someone who can repair this? The difficulty isn't even going to be finding somebody with the skills so much as somebody who will work on it for the amount of money that a T430 is actually worth. That's a big part of the issue in this industry. A little kiss of wick. Yes. I couldn't help myself. Call it OCD, I can't help myself. I need my pads to be wicked. I'll go to sleep tonight and it'll be bothering me. I'll be thinking about those little pads that weren't wicked. We'll replace that cap later. It's probably for something... It's probably not for something important. Do you know which brand of flux Jessup prefers, Paul? Is it Chipquick or Amtech?
Oh, that would be Amtech. We don't have any of that flux that turns into hard diamond-like substance on the board.
When fixing iPhones for data recovery, Paul, do you reheat the CPU before or after you get the data?
After. Always after. Because then you have to get the balls out of from underneath the CPU so you could send them to iPad Rehab to get the data out of them.
One, two, three, four, five. Uh-oh. Here, micro soldering pencil.
Uh-oh. Please find it.
That beeping really does add a sense of urgency to finding it.
You're stealing Jason's?
I'm stealing mine back. Who's saying "re" in my chat?
I turned it off.
No wonder it wasn't getting hot.
What could you have done with that hand?
You could turn the buzzer off, but it requires reading the instruction manual, which is an attempt to hold my time hostage. I can't be asked to do that. How does hot air not blow SMD components away? Surface tension. Don't you go re? Is Pepe still on the desk? Yeah, he's behind my microscope at the moment.
Looking a little drunk.
He's a Pepe. He's my Pepe. Jessa says, I thought you said Paul did nice things around the shop. Why has he not turned off the Hacko alarm? I think he likes the beeping.
Well, can you turn off just the non-tip alarm? Because I still want the heat.
I love the little beep when it heats up. When it heats the temperature and goes beep.
Yeah, I want that beep still.
John always used to yell at it with his Albanian accent. Beep, you piece of shit. Beep! And then you go, as soon as it came to place. It was an office meme. How rare is your Pepe? Oh, it's rare. Believe me. It's as rare as someone pursuing corruption within the DNC that doesn't get robbed or commit suicide. Which is pretty damn rare. Okay. This thing down.
You lost a cap?
Yeah. It's some stupid thing to ground. I don't care. This is quite a tight space here. Do you have a 390A meter as well, or did you set up the serial one that Lewis uses? You think, Paul, you just have the regular fluke without the...
Yeah, I haven't messed with the BK Precision. I just have a regular fluke on my desk.
Hey, Vladimir, how are you? And T. All the regulars are here. Damn, I can't get a jumper wire on today. I fucked this up. Oh, damn. I said something I wasn't supposed to say.
Ooh, told you.
I have to get a jar for every time that happens. Every time that happens, I have to put 1 Dogecoin in the jar. Sorry, parents of kids watching. I will do better next time. Put 1 Dogecoin in the jar for me. Jesus, why is it so hard to do one pad today? I feel like I've lost the superpower. I've become a noob. I've become a total noob at this again. This is what it must feel like to enter your 40s in Hollywood. Jeez. Dogecoin. Alright, so we've got our...
We don't have anything to use as a swear jar.
Hide your Dogecoin inside the Pepe. Yeah, I have to put a Dogecoin inside of Pepe. 1 Dogecoin. That is some grade A cheapskates, it's just. That is worth 0.7 cents. Oh, man. Wait a sec. I'm killing myself to attach it to this when I could just be attaching it to the cap. Really? Really? Oh man, I'm dumb. That's dumb. That's dumb as Dogecoin. Okay. So let's see if we get any difference. We're probably going to have a lot more components we're going to have to mess with, but let's see if we get any difference just plugging this in right now. Dustina says, I hope I never have to go through customs with the fear of them checking my Pepe for Dogecoin. Jessa says, Emma's homework would round 1 Dogecoin to 0. Oh, it's this fuse now. Oh!
20 volts.
Wait, let's just move that into view so that they can see. Much Dogecoin.
CPU.
Wow. Power. All right. Let's see. If I get CPU V-Core, then it'll actually be worth it reattaching all that stuff. Much coin. We do not fear the touch bars anymore. Today I will live as a free man. I will no longer be a technician that cowers under the touch bar. Okay, so I'm looking over here. I was looking in the wrong space and being an idiot. And we're going to see if we get CPU V-Core, because that would mean that it's turning on. And it looks like we get 0.6 volts of CPU V-Core, which means it's turning on. Well, we're 2 for 2. We're not afraid of touch bars anymore. schematics and board views. Beautiful. Now, somebody has to reattach all of those ESD protection diodes.
Son of a...
Somebody. Let's see. Who here could possibly do that? Nobody over there. Hey! There's somebody over here! ESD protection. I should leave that for...
Where are they?
They're everywhere. They're all missing pads, too.
Oh, God.
Oh, dear God. God of Doge.
Oh, it's right to a VIA, too? Oh. That's awful.
Did I...
Oh, I'm not connected there. I'm still connected to my dongle.
Oh. Yeah, never mind. So... Well, that's not going to be fun. I should reattach those tomorrow. I should reattach those because I value ESD safety and ESD protection. And I would never want to undermine the ESD and safety protection of a device that we worked on. Time for you guys to break out a couple of iPhone 7 with boot loop. No, we refer all those to iPad Jihad. I mean iPad Rehab. Swearing a non-English count. Yes, you can't get around it by swearing in non-English. So, I think that's the time to end this. We did get a victory. We got VCore. Why ruin it? Oh.
And we got a hold of the schematic and board view.
And we got a hold of the schematic and board view.
That's huge.
And I think I do believe Jessa kicked Apple's ass this week, from what I've heard, which means that, yeah, it's been a pretty good day, pretty good week. So expect to see some more touch bar repairs on the channel. Expect to see us go over more of the common flaws, the common issues that go wrong on these, since we now have access to the tools, parts, and diagrams that make doing this economically viable and worthwhile. Now, just to revisit what it was that went wrong with this one, it looks like that we have an IC that controls the, we have a chip that controls the USB port, USB-C, all the USB-C stuff, and that is going to be CD3215 right over here. Let me see if I can make this nice and full screen for you. Oh, that's not full screen. That's TwitchCat. Give me my full screen. Give me my full screen. Beautiful. There. What are you doing?
Oh, these capacitors aren't that important.
Shh. You don't tell them.
Well, it'll run without them. I wouldn't leave them off, but it'll run without them.
Yeah. Nice save. Anyway, so this IC is the chip that talks to the charger on this USB-C XB CC1 line. This bi over here stands for bidirectional data line. And that bidirectional data line is, let's see, does it go through this? Looks like you go through this before becoming, oh boy, this is much more complicated than the old schematic. All right, let's see if we can follow this to its natural conclusion. And then this is the connector. So this over here, J3300, is a connector. It looks like a chip, but it's just because they decided to draw it funny. This here is actually a connector. So that is where USB-C XB CC1 goes. The bi stands for bidirectional, which leads me to believe it is a bidirectional data line. So this IC needs to get its PP3V3 in order to function. And PP3v3, before going to this, goes through some type of resistor first. So over here you can see PP3v3 underscore G3 hot needs to go in on the top of the chip. And on the top of the chip, that's where you're always going to see your VBus or VIN, VDDIO, VCC, VIN. It's all the same stuff. VIN, voltage in. VDD, something to do with the drain. VCC, something to do with collector. But the whole idea is the pins that are on the top of the chip, when it's in the schematic, the way it's designated in the schematic, this is always typically going to be for voltage going in, and you're going to need that in order for it to work. Now, PP3v3 G3 hot does not go directly to the chip. It goes through this 0 ohm resistor that I imagine acts as a fuse first, and this was completely burned off of the board, so we just jumpered a wire over to bring PP3v3 underscore G3 hot over to the USB-C controller, but only after ensuring that there was no short circuit to ground by measuring in ohms to ground at this point. And when we did, it worked, it turned on, it had V-core, and if it has V-core, well, I'm sure the rest of the machine works. Not like we need to, test it or anything like that. We'll leave that for Monday. So that's it for today. Thank you very much for watching, and as always, I hope you learned something.